Hello, this is John from caveofprogramming.com, and in this tutorial I'm going to animate my ball sprite so that it moves around the screen, so it bounces around the screen. And a lot of what we're going to do from now on is not going to be Android specific, and if you just want to look at the Android specific stuff, then you probably want to skip ahead till the stuff that we're going to do on sound. Because I think until then probably there's going to be some stuff on getting touch coordinates, but most of what we're going to do here is going to be kind of general kind of game programming type stuff until we get to the sound bit. And at the moment what I've got is, if I go to my game, let's go to all apps here and start my game from the icon. Then it starts off with a ball, and this is actually moving smoothly, but the problem is that on the screencast it looks jerky, which is annoying. But if I run it in an emulator it's just as bad. So I'm not even sure if it runs in an emulator. I think last time I tried it didn't work, so I'm afraid I'm going to have to ask you to bear with me and to trust me that it does actually move smoothly in real life. And in real life the actual drawing looks quite a lot nicer as well, because the screencast expands it to like 1.5 times its actual size. So at the moment the ball just plows ahead and jumps right off the screen, and what I need is some code in update here to detect when it hits the edge and to make it change direction. And I'm going to do that initially crudely, but we'll at least get it basically working in this tutorial. And I need to give this sprite class methods for getting the actual bounding rectangle of this image. So I'm going to give it a method called public rect get rect, which sounds like a command to get very, very drunk if you're from Britain, get wrecked, but it's actually get the rectangle that bounds the actual image is the meaning of it. And I'm going to, up here, let's create a private rect, let's call this bounds, and yeah, that should do the trick. Let's add the input for rect there. And to calculate this rectangle, what I'll do is, in init, where we load the image, I can then say bounds equals new rect. And if I just do control space, we can see how the constructor parameters work. And we've got the left, top, right and bottom of the rectangle, and this is going to be relative to the image, so the left and top are going to be 0, 0. The y coordinate is actually goes from the top down, so the topmost bit is going to be 0. So what was that? Left, top, right and bottom, and the right is going to be image dot width, get width, and bottom image dot get height. And now that's the bounds relative to the bitmap itself, and I can return that in get rect, so I can say return bounds. But I also need I need to know the rectangle actually on the screen, so I'm going to give it a public rect get screen rect as well, and this is going to return the kind of the rectangle that the image covers actually on the screen. And to do that, I'm going to say rect screen, actually let's call it rect, equals new rect, and the left is going to be bounds.get well, actually it's going to just be x, isn't it? It's going to be x, and the y, be nice if I could get the constructor here. Let's do control space. Left, top, right and bottom. So the left is going to be x, right is going to be x plus bounds dot, let's say get bounds. Oh, I called it get rect. Yeah, that's good. Get rect dot width. So is that right? So the constructor's left, top, right, bottom. What am I doing? This is all wrong. Okay, the left is x, the top is y. Left top, right is x plus get rect dot width, and height, and the, I can't keep this in my head, left, top, right, bottom, and the bottom is going to be y plus get rect dot height. I think we're there. So this is the same rectangle, it's the same size as this rectangle. The only difference is we've got to add x and y onto, x adds onto any coordinate, any horizontal coordinate, and y adds onto any vertical coordinate, and then we can return that. In fact, why not do this all in one step and just say return new rect? I think that should do the trick. Now there's an error here, and that's going to be because I have to use integers for the constructor here, which is a bit annoying. And I suppose I could say, because like width is returning, well, x is certainly a float, I could just put a bunch of typecasts in here, and by the time we're talking about the screen, then everything has to be boiled down to an integer anyway, because the screen's obviously, screen positions are specified in pixels, so it wouldn't do, there's no point in trying to specify the screen rect in terms of floating point values, because it's got to be boiled down to integers anyway. So I'll use a typecast. I could use math.round if I want to be really finicky, but I think that for our purposes here, just casting to an integer, which would chop off any part that goes over the lower bounding integer value, would be fine. So, you know, if we say 8.9 and we cast it to an int, we're going to get 8. But I think that's fine for our purposes here. Now I can go ahead and use that to make the ball bounce, because I can say here, so after we add the actual kind of speed and direction, I can then say rect screen rect equals get screen rect. So this is telling me the rectangle of this ball actually on the screen, and then I can say if screen rect dot get dot x, is probably what I want, I think, screen rect dot left, that's the one, is less than or equal to 0, then obviously that's no good. So what I need to do is I need to say that the x direction is then 1. So that, like, the x direction is going to be -1 or +1, and it's going to be -1 if we're heading left and +1 if we're heading right, because if it's +1 then we're going to add the speed, which is always positive, times the elapsed time onto x, which will move it to the right. And in fact, let's do the addition down here like that. So if the left corner of that rectangle is off the screen to the left, this says, then make sure, change the direction to 1. I mean, because presumably the direction must be -1, and that was how the left got to be less than 0. So we're going to make sure it's 1, and then we're going to be adding to x to move it back towards the right. I'm going to say else if screen rect dot right is greater than or equal to the screen width, screen, and this is what we need the screen width here for, and actually I need to have get methods in my sprite for the screen width and screen height. Let's go ahead and define those, because the sprite does have this information. So I'll right click and go to source, generate getters and setters, and I don't think I need setters, but let's tick get screen height, get screen width, and that should do the trick. And so here I'm going to say if screen.right is greater than or equal to get screen width, then I need to turn the ball back the other way and say direction x equals -1. And it's going to be exactly the same again for y, basically. So if screen rect dot top, and remember that we numbered down from the top down on the y-axis, so top is going to be the smaller coordinate. So if screen dot top is less than 0, it means it's off the top of the screen. We want to say direction y is going to be 1. And else if screen rect dot bottom is greater than or equal to, and this one's going to be get screen height, then direction y is going to be -1. We want to start subtracting from y, and I need the equal sign in there. Now if I've got this right, now we're going to see the ball bouncing crudely around the screen. It's going to be crude because, well, firstly you're going to see it as being crude because my emulator, my screencast won't keep up with my phone, but also because this screen rect is the rectangle of the entire bitmap instead of just being the ball. So it's not going to be perfect, but well, you know what, I forgot to start my emulator, so I'll be back in one tick. Okay, did I say emulator? I meant screencast, but anyway, here it is, it's running, and although it appears jerky to you, unfortunately, it is actually animating smoothly, and the ball doesn't look as jagged as it does, unfortunately, on this emulator. And you can see that it's bouncing around the screen, but you'll notice that it's not hitting the exact edge of the screen. It appears to stop short of it, and that is because the bitmap has a transparent background which is bigger than the actual image. And to fix that, the sensible and efficient way of doing it would be to make your bitmap fit your image precisely. And I haven't done that just because I want to combine this image with its shadow. And if I made the actual bitmap smaller to fit the actual image that's on it, the actual non-transparent bit, I'd have to then manually line up the shadow with it, which would be a good thing to do. But just for kicks, and because I'm very lazy, what I'm going to do is, rather than fill about with pixels manually and try and align the two correctly, what I'm going to do is I'm going to just write a little algorithm in the next tutorial which is going to find the non-transparent region of that bitmap. So we'll do that next time so that the ball will bounce more precisely, and I'll leave it there for this time, and until next time, happy coding.